We will now look at another one-tail test. This will be the last test we will do with calculated critical limits. From here on out we're going to do it another way, but we're going to do this particular test both ways, the way we have been doing it and then the new way in a little bit. Alright, so here's the problem. A simple random sample of 400 items from all the items filed by a clerk during a week contained 10 incorrectly filed items. Assuming that a 2% error rate or less is satisfactory, would you conclude that his or her work is not satisfactory? Use an alpha of 1%. Alright, so this is a proportions problem. We have a sample size of 400. Sample proportion then will be 10 out of 400, which will be 2.5% error rate for the sample, and we're going to compare that to the prescribed limit here of 2% as a maximum error rate for the work to be satisfactory. Alright, would you conclude that his or her work is not satisfactory? So this is a one-tail test because of the 2% or less, and we're doing proportions. Now let's write down our sample data. Alright, so sample N is 400, sample proportion 10 over 400, and that's 2.5%, 0.025. Alright, so is the work satisfactory? Is the question. In this case, satisfactory means that the true error rate has to be less than or equal to 2%. So this is a one-tail test. Alright, with all one-tail tests, for z-tests, we then ask ourselves which tail. We do that by finding out where the sample data is in comparison to the middle of the distribution. One way of doing that is to do the following. Write down your sample value, in this case a sample proportion of 2.5%, 0.025. Compare it to the middle of the distribution, the 2%. Alright, 0.025 is greater than 0.02, 2.5% is greater than 2%. So this is an upper tail test. And the alternate also has that same sign in it, so it's the greater than sign. So instead of p hat being greater than 0.02, we'll have the population equivalent of p hat, so that'll be p being greater than 0.02. Alright, the true error rate is greater than 2%. Alright, so now we can write down both hypotheses. The null and the alternate. We'll write the alternate first since we already have it. P greater than 0.02, and then the null will be the complement of that, p less than or equal to 0.02. If the true proportion is less or equal to 2%, the work is satisfactory. Of course, the alternate is the complement of that, so it is not satisfactory. Alright, next we're going to draw a distribution. This now is sample proportion, so this is the sampling distribution of sample proportions. The middle of that distribution will be the p of 0.02. It's an upper tail test. Put the entire alpha up there. Let's go back and see what the alpha was. Alright, 1%. So the alpha of 1% goes entirely in that upper tail. We need several things to calculate that upper limit. We need the standard deviation, sigma sub p hat, and we'll do that over on the side here. So sigma sub p hat is equal to the square root of pq on n. Alright, remember it's the square root of the whole thing. Or if you like, the square root of p times 1 minus p on n. Alright, it's the same thing. Alright, so p 0.02, q, or 1 minus p. Alright, be very careful, that's 98% or 0.98, divided by the sample size of 400, and then we'll take the square root of that whole thing. Alright, so let's now do that calculation. So in Excel, if you're going to do it that way, it would be equals the square root of the parentheses for the top line, 0.02 times 0.98, close parentheses for the top line, divided by a sample size of 400, close parentheses for the square root, and we get precisely 0.007. Okay, so that's our standard deviation of that distribution. Next we need the z-value with 1% in the tail. We need to go to our t-tables to find that, and our t-tables with 1% for the z in the upper tail is 2.326. Alright, now we're ready to calculate that upper limit. So, upper limit is equal to p plus the z-value with alpha in the tail times sigma sub p hat, which will be 0.02 plus 2.326 times 0.007. Alright, so now let's go back to Excel and work that out. So that will be equal to 0.02 plus 2.326 times the 007 standard deviation, and to 4 significant places that's 0.3628. Alright, so 0.3628. Alright, so if the null is true, if the work is satisfactory, we'll have sample error rates, sample proportions all the way up to about 3.6%. Beyond that, error rates are unlikely to occur if the work is satisfactory. Okay, so from there we do our decision rule. Alright, so first part, the acceptance region. If, we're doing sample proportions, so if p hat is less than or equal to 0.03628, null is possible, so do not reject the null. possible the work is satisfactory. And then for the rejection region, if p hat is greater than that value, 0.03628, then sufficiently far enough above the 2% so we can reject the null and accept the alternate. And for the interpretation, it is likely the work is not satisfactory. Alright, now we go back, find our sample data, sample proportion of 2.5%, 0.25. Where is that on our diagram? Well, 0.25 is somewhere in the middle of the acceptance region. Okay, so we go with part 1 of the decision rule. So decision, since p hat is 0.025, which is less than critical value of the acceptance region, 0.3628, do not reject the null. Alright, so that's well within the region that we fully expect to see sample proportions if the work is satisfactory. Alright, so it is possible the work is satisfactory. And that's the end of the test done in that particular manner.